It's not like I'll go in and tell you now, in case you're wondering. I'm never going to ask for this packet, so you may be thinking, oh my gosh, I've been filling it out in case you want it. The rest of the packet's a guide. Well, the first of the packet kind of was too, but it's just a guide through this section, this unit. Grace, what I was saying is I'm going to use some more examples off this packet, but I'll never take this packet up. You can use it. It'll be one of your study things for the test. Identities never go away. If you really tried your homework, which I use that word really a lot, if you really tried your homework and put your mind into it, which you're finding in honors pre-cal, things are probably amped up a bit. You should at least. So you've got to really process your homework or you'll fall behind. You can't just do your homework. You've got to really, really try. If you really, really tried, you realize now what's just happening is with identities, which we'll keep doing them, by the way, as we add new identities to our memo page. With identities, what happened was I gave you an expression and told you what to change it into. Now you're sort of flying on your own. You've got an equation you've got to solve. You can't solve because it's got two different trig words in it. And so you've got to change it into something that's convenient to work with. So the identities you were just in training until you learned what to do. And now I've got to manipulate my equation so that I have any hope of solving them. Now, hopefully you have that feeling of what happened. Me telling you to look at the examples in the book, I had two choices, three. I could have just not even given you those yet and explained them today, which I thought about, the ones at the end of the homework. The other options, as a teacher, I could have said, an honors fast moving class, look at the examples because I need to start pushing you out of the nest. And you need to have the feeling of when you're in college or in AP Calculus that your teacher's done so many examples that they can do in class, but you might need to look at some more with your highly intelligent brain and see if you can figure it out. The examples in the book are really good. If you didn't look at them, they're very helpful. As you're studying, I would look at your text. And the third thing I could have done was made a little video of me working those problems or problems like it. But I felt like we're at a point, I hope, where some of you actually got to that. And you looked at some examples in the book, and then you were able to at least somewhat work the problems, okay? But I opted for, I thought you were smart enough to do it yourself. Our slides today are from, these are really actually from my Instagram story, in which case you're not supposed to put students in your Instagram story, and I always abide by that, but I see other teachers don't, so it was really fun. So in my story, they gave a tour of Marymount during the Christmas fair. So these two girls, well really there's three of them, for some reason I just got two in there. So they did welcome to Marymount, and then I just followed them through the building while they explained everything that's going on at Marymount, all the way to the outside. It was really cute. But anyway, so I just took screenshots of it. Here we go. On your homework, let's look at, let's see, was it 278, or am I thinking about my calculus class? 373. Okay. All right, on 373, okay, so let's look at number 35. All right, so this is number 35. Number 35 on your homework was 4 cosine squared x minus 1 equals 0. Most of you probably did 4 cosine squared x equals...
We started at 37.
Oh, okay, well, let me finish this one. Okay, thanks. So maybe I'd already assigned these. 4 cosine squared x equals 1/4, so you're just watching. Then I square root, like Rebecca and I talked about before. That's when you have to put the plus or minus on when you've got to square root a situation, okay? Hopefully you understand why. Cosine x equals plus or minus 1/2, okay? Option 2, though, would be to factor. Before you do anything, you should look through your problem and see if there's anything in common. Don't divide it out, factor it out. That's huge. This is really a difference of squares. This could have been 2 cosine x times 2 cosine x, and then plus 1 minus 1. Do y'all see what I mean? So it just kind of depends on how your brain works. You start to see as I'm going over things that I spend a lot of time grading these papers, grading these tests, because I'll have to see what your brain thought of and if what you thought of was the right thing. This person would have gotten cosine x equals negative 1/2 and cosine x equals positive 1/2. Same thing if this was person student 1 and this was student 2. You're still looking at the same stuff. As we continue on though, girls, just like in problems like this, you know, like in algebra, when you were doing problems like this, you could get extraneous roots. Like if I ended up solving this equation that I just made up and I got an answer that was either 0 or -4, I'd have to throw it out because I didn't realize this till I was in pre-cal. I kept wondering why I want to get extraneous roots until I finally realized once I do my first algebra where I would multiply both sides and get rid of the fractions, I've now really changed the question to where there's no denominators anymore, and so the question thinks that everything's domains are real numbers, okay? So let me say we got to keep an eye on our words. What do I mean by our words? Sine and cosine are the only two trig functions that are defined everywhere. The domain of sine and cosine are all real numbers, so I can relax, okay? Just like I relax if I have a polynomial. I'm not real relaxed if I have a square root or a logarithm or something because there can be some problems, or a fraction. A rational function is what that's called. But y'all see we're going to have to be on our toes if we've got something like secant or tangent because it's undefined sometimes. So I've got to double check my answers back in the original, or at least make sure it's defined. It's just time for me to say that. It doesn't happen here. I'm relaxed on the cosine graph. In our class the other day, we talked about what would happen with cosine. Does anybody remember? I know that a couple of y'all do because you were engaged in the conversation. If I graph cosine, it goes up and down. What happens if I graph cosine squared? Then it's going to all flip up and it's going to be kind of like a scalloped edge, if you know what that is. Like on those cute Mary Mock shorts they were selling. Didn't I got those on? One of my advisors already. Did y'all see them? They're so cute.
Yeah.
Anyway,
Was it Kira? Was it
yeah.
Kira who had them on?
Oh.
Yes.
Wait, are they like pajama shorts or like?
Yeah. They're like, huh?
Should I buy a pair?
You've got to buy them on the store and they're really cute. Yeah. I think they're like $25.
Oh my gosh, I saw a pair of fuzzy pants.
I don't
The fuzzy
pants.
stars. Okay, anyway, I think only in my room can we digress from a cosine squared graph to sleep pants to fuzzy star.
They were so cute.
Yeah. My former students would not be surprised at that at all. Back to trigonometry. Okay, so it does this. The 4 would give it an amplitude change, and the -1 would bring it down, you know, all that kind of stuff, okay? So also visualize the graph. On some of your homeworks as I was walking around, I saw some of you even like had some picture sketches of what was happening. Now, girls, this said, and this is what we're really going to work on a lot today, the instructions on the one that you didn't have last night, number 35, it just said find the solutions. So how many solutions? It said find the solutions. I have to name every time that this happens on this graph that must be doing something like that, okay? All right, so my first thought, that's why you're supposed to be, I'd love to think you're not even really using your memo page. A lot of you are like, it's like you've sprained your ankle in your own crutches and you're kind of scared not to use the crutches anymore, but you don't really need them, but they're there in your room if you need them. That's what your 1, 2, 3 chart is for. But if you don't really know your stuff, you're not going to be very successful on these. Hopefully everybody thinks of a 60-degree reference angle here.
Yeah.
If I do it in radians, I'm going to use all my pi over 3s. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. By the way, if you feel like you need more practice on where the radians are around the circle, remember that radian game is still up under topics. That you could look at that, okay, and practice. That's not the only time it happens. That's the first time it happens in a cycle. And so I would add plus 2 pi k, where k is any integer. However, here's pi over 3 and 2 pi over 3. Not really. It's more like this, pi over 3 and 2 pi over 3. And here's 4 pi over 3 and 5 pi over 3. What do you notice about pi over 3 and 4 pi over 3? How far apart are they? 180 or pi radians apart. So I might have a student on this test, or if you look it up in the back of the book, I want you to understand what you're seeing. Remember how we talked about it wouldn't do this anymore? And so when you square sine or cosine, it shortens the period like that. Ironically, let me go on and tell you, it does not shorten the period of anything but sine or cosine. We'll talk about that on the next slide, okay? All the other trig functions, squaring it doesn't have the same effect. It won't, I'm sorry. It happens with sine, cosine, secant, and cosecant. With tan and cotan, their period remains unaffected even if you square it, and I'll show you why in just a minute. All right, but anyway, another student could have said pi over 3 and 2 pi over 3 plus pi k, where k is any integer. Yes, I should always write what k is, because sometimes I don't want k to be any integer. I want it to be every odd integer or something like that. We haven't run into it yet. But you can't just say that, except on your homework. On the test, you need to tell me what k is. Some students at the top of the page write, when encountered, k is any integer. And then you can tell me otherwise if you find it somewhere on your test that you want it to be something different, okay? But you can't just leave it, because somebody might go, I want k to be 1/2, and that won't give them the right answers. What does this do if you haven't caught on? Is this finds the first couple of answers, the first couple of birthdays, and then it just goes like this to find all the others, forwards and backwards. All right, so it's a great way to say it. Questions? Chloe?
Yeah. So is it acceptable to just put the first one in the circle?
That's acceptable. That is correct. Okay. Now let's look. Bless you. Let's look at this. I think this is the welcome to Marymount slide. Welcome to Marymount. Okay. Let's look at. Here's sine, and left unattended without effect, your period's 2 pi. If I did sine squared, wouldn't it do this? Okay, so what Chloe was asking me, suppose I asked when sine squared equaled something, okay? You could name this one, this one, this one, and this one out to 2 pi. And then if you add 2 pi k, it will repeat all of those that you found. That would be correct. But y'all see that you could just grab these 2 yellow ones and add pi, and it would catch these and these. Any question on that? That happens with sine and cosine, and secant and cosecant. Let's look at secant squared. Okay, so secant is the one that hits right here at 0, 1. Because it's a reciprocal of cosine. Its domain is not all real numbers. In fact, the way to even say the domain, you would need a plus pi k thing, okay? This is undefined every pi over 2 radians. Cosine is undefined up here and down here as you're rotating around your circle, because you have no x-coordinate, okay? So anyway, it's undefined. At x equals pi over 2 plus pi k, where k is any integer. The domain is all real numbers except these. So if I wanted to name the domain, I would say x cannot equal pi over 2 plus pi k. Do y'all see it's undefined every pi radians? Do y'all see that? This one is pi over 2 plus pi is 3 pi over 2, which is the next asymptote I encounter. Can y'all kind of see their pi radians apart? Okay, so that's where it's undefined. All right, that was just a side note. When I square it, what is 1 squared is 1. If this number is like 3/2 squared is 9/4. So they change slightly, but it basically still looks like this. But what will this one do if I square all of those numbers? So you get all of these series of u's. Do y'all see what I mean? Okay? And so now the period's not really 2 pi. Do you see that the period just shortened? You get a u every pi. All right? Now let's look at this. I think I've shown you this before. Tangent squared x. Do you remember what I said about tan? Will it change the period of tan or not? I said it wouldn't. Let's look at why. These tangents repeat every pi radians. The asymptotes are the same here. They're undefined every pi over 2. Okay? Every time you hit 90 and 270 as you're going around your circle. So I have all of these. All right, if I square it, 0 squared is 0. If this is like 1/2 squared is like 1/4. So these numbers change slightly, but not a whole lot. What happens to the ones underneath? Okay, so I get this. Okay, did it change the period? It still repeats every pi. Some of y'all probably also noticed this. What if I do tangent squared x plus 1? Is everybody looking? Tangent squared plus 1 is, I'm sorry, I should have drawn them at the same whatever, but do y'all see what I'm trying to do here? So sorry. I should have drawn them to the same scale because that's not quite as impressive as I wanted it to be. But do y'all see what I mean? Okay? And so do y'all see this is quite literally tangent squared plus 1 up there. Secant squared is tangent squared plus 1. All right, so that was a lot of stuff, all right, that just sort of was neither here nor there. Now, questions on your homework. Let me not just pick problems. Why don't you pick the problems? 45. This is number 45. All right, 45. All right, so 45 is 2 sine x plus cosecant x equals 0. One thing that we talk about in the math department when we're looking at like placements for like the next year or somebody coming into Marymount that takes like an entrance exam, just so we can place them in the right math classes, we look for a great degree of fluency in mathematics, just like if you were fluent in Spanish or something like that, okay? So I felt like in Algebra 2 that I was sometimes getting caught when I looked in the back of the book going, why didn't they include that number? And then I'd go back and realize, oh, well, it's not part of the domain. It doesn't fit back in the original. It always aggravated me to have to go back and check my answers when I felt like I worked it correctly algebraically. Y'all all understand, though, if you start with a square root and you square both sides, you've just now opened it up for different possibilities. As soon as you start your algebra, you're changing the equation, and you may be allowing people in that don't belong, okay? It'd be like if you were taking your kids to a movie, if you had kids, which I guess you don't. I've taught students that have kids before, but you apparently do not. But anyway, if you're taking your kids to the movie and all of a sudden like the R rating like fell off the sign and you just went on in, I always wonder sometimes why kids are even in those movies, which does happen. But in any event, you know, you don't want to. They don't belong in there. Okay. I tell you where I really notice it is the first comedy show I went to in New York City. They were like, "Oh, it's family friendly. It's like PG-14." Oh my gosh! Like, it was so embarrassing to be sitting there with like a family that apparently had just landed in New York with their like 14-year-old sitting next to them, hearing all that same stuff I was hearing. But be that as it may, I wanted to go. You are not in the domain. Take your child. And I kind of want to leave too, but that's beside the point. Okay, so anyway, all that to say, if you're fluent, you're going to be aware of it from the beginning. Please don't wait to the end and go, oh, I better check my answers. Okay? There's a problem with this already. Do you see cosecant? Mm-hmm. You know the picture. Remember how much I harp on pictures, okay? I really stress that. Cosecant has a lot of undefined places, so you better watch out. Because I'm about to change cosecant to sine so that I can work the problem. So my problem's going to go everything sine, all right? I'm aware on the front end that I have a problem. Okay, so if I got to work this by hand, I'm going to change this to 1 over sine. So now you're kind of on your own working an identity without knowing what the right-hand side is. Do you see? You've now got to change the left into something that you can work with. So now you're solving an equation, okay? But what is your next step in working identities if you have a fraction? Common denominator? All right, so I'm going to get a common denominator. I'm going to multiply this by sine and this by sine. That gives me 2 sine squared x plus 1 over sine x. We get a little bit of salvation on this problem. Lauren and I were working it this morning. What's the only way for a fraction to equal 0 is if the numerator is 0. Would y'all agree with that? As long as the bottom's not also 0. So I got to watch for that. I can't let sine be 0. I've known that since the beginning of the problem. Cosecant's 1 over sine. I cannot encounter a time when sine is 0. However, when we set this equal to 0, I immediately realized there was a problem and got Lauren to check the back of the book to make sure I'd worked it right. Because I'm like, this doesn't even have a solution. Because I'm thinking graphically. Think of your sine graph. Think of it squared. Think of it doubled. And then add 1. Are you ever going to encounter 0 if you do all of that?
No.
Do y'all see logically, like if you're thinking about the picture, if you square it, it's going to be positive and hit 0 every now and then, isn't it? But if you add 1 to it, you're not going to ever hit 0 if I drew this graph. But let's keep working. Suppose you didn't notice that yet. So I have 2 sine squared x equals negative 1. So you might be happily working your problem, and you see now you run into an issue? So you can't square it in negative because we're working in real numbers. And so this one actually has no solution. And so it's interesting, we're not going to do it right now, but if we graph whatever that is, it just never hits 0. When I say we have a little bit of salvation here, I got no solution, so I didn't even have to worry about extraneous roots. I didn't even have any to check. Okay? But y'all see what I did? What happened there was basically I had the left-hand side, and I myself had to change it into something I could work with. Nobody's telling me anymore what I need. So you're sort of on your own now after training. Okay? All right. Is that okay? All right. Another question? What else?
51.
All right. 51. All right. 51 is 4 sine squared x equals 2 cosine x plus 1. Okay, so now I'm in trouble. If you looked at I can't even do anything with that, okay? If you look at the examples, though, they suggested that you use identities. What will I use, Katie?
The 1 minus cosine.
Okay, so Katie's going to sine squared x plus cosine sine squared x plus cosine squared x equals 1. And so what can she replace sine squared with? 1 minus cosine squared. So why you learn the identities. All right, so now what you do, once you set up a problem in pre-calculus or in calculus, it's really just an endurance sport. If you think about almost all that we do in this class, and honestly, if you ask my students in AP Calculus BC, after we do our first step, we're almost always in algebra. And it just means I'm standing here and don't go, I don't know what to do. Take the next logical step. What's the next logical step? Distribute, okay? So this gives me 4 minus 4 cosine squared x equals 2 cosine x. Does everybody see a quadratic here? So I'm going to get it equal to 0. I like my quadratics to start with positive. I have a better chance of factoring it. Bless you. Now, part of my test, we will have a choice of some of them. I'll just say solve. And guessing in the past, I usually will say, if I say exact answers, that means you might as well not use your calculator because I'm looking for numbers like 2 pi over 3. Okay. But if I just say solve, you can do it however you want to. But, however, I think we'd all agree, instead of typing this into our calculator, waiting for it to graph, doing calc 0, or whatever it is you're going to do, we'd all do it faster if we could do it by hand. So remember the discriminant, b squared minus 4ac would tell you if this would even factor if you get a perfect square. I think this one does factor. We're going to do it using that. There was something else I was going to say here. Oh, I know what I was going to say. Let me go on and work the problem, then I'll introduce sort of a new concept for today. All right, so this is 2 cosine x, and 2 cosine x is probably what I would honestly try first. That may not work. I don't remember what's going to happen. So I'm going to go to 3 and 1, and it looks like I can get a 2 in the middle. This gives me 6. I'm going to make this positive. This gives me 2. I'm going to make it negative. But I kind of thought I might have to change the 4 to a 4 and a 1. That's right, isn't it? 4 cosine squared plus 6 minus 2. Okay. So now I get cosine x equals 1/2, which gives me, did it tell me what to do it in? Huh?
I think that's right.
Okay, good.
Because then you get 4 in the
It felt really good to me. Oh, I was thinking I wanted 4 in the middle. I don't want 4 in the middle. I want 2 in the middle. Thanks, Brianna. So that didn't work. Let's go back to my little smiles. Thank you. I can't add today. Those are my smiles. Brianna tells me that does not give me 2. That gives me 4. All right? So I was just checking. I was testing y'all. So I guess I need to go back to 4 and 1. Okay. So I'm going to make this 4, and I'm going to make this 1, but that won't work. I can already tell. Do you see that big 12 right there? Okay. So with the little trial and error method, I'm going to make this 1, and I'm going to make this 4. I'm still not getting it.
I know.
Let's do b squared minus 4ac. b squared minus 4ac. 4 plus is 52.
Yeah.
So it won't even factor.
You have to like use the quadratic.
Oh, I'm sorry.
factors and then-
It said graph it. I didn't read the instructions. Okay, so this is a great lesson. All right? I'm sorry. But I accidentally made a really big point here about 12 different ways. Really 4 different ways, okay? Huge things about to happen. I should have read the instructions. First of all, I'm kind of not sorry that I at least got you that far by putting in an identity. And I do this in AP Calculus also when I'm about to show you, okay? When I go to my calculator, wherever it is, watch what I'm going to type in. I'm going to type in 4 sine squared x oh, sorry. I'm treating it like a computer, and that's not going to work. Okay, 4 sine x squared. 4 sine squared x. Now watch what I'm going to type in. It might surprise you. I'm not even going to look. Watch this. I'm not even going to look below here. I'm going to say minus 2 cosine x minus 1. Okay? Let me tell you why. There's actually a calc 0 and a calc intersect button. Okay? I could have typed 4 sine squared x into y1 and 2 cosine x plus 1 into y2 and looked at where they intersect. Do you notice how ugly that's going to be? I'm going to have a scalloped edge thing with a, I'm going to have 2 graphs swimming around in front of my face. Are y'all with me there? Okay? So do you see how I brought it all over and made it one equation? The reason that I did it from that moment, this is huge. This is really big, okay? The reason I did it from that moment, from just watching me, like I said, I made a really good point accidentally, which happens a lot. I could have messed up anywhere in here, and if I typed that one into my calculator, I might not even be typing in the correct equation. I may have made a careless mistake. So on your test and in your homeworks, if they say use a calculator, use the equation in its purest form. That means you're probably not going to be able to factor it anyway, so did I just wasted all of that time just to encounter something I need my calculator for? I couldn't factor it. I'm not going to do the quadratic formulas, okay? Not about to. Girls, if I did the quadratic formula with that? What are the chances I'm going to go cosine x equals 1 plus or minus square root of 5 over 2?
Yeah.
Okay? So at the end of the day, I'm going to need a calculator anyway, so I hope you're this. If I had read the instructions when they asked me for this problem, I wouldn't have done all of that. Okay? Unless I was trying to make a big point. Now, if I did it right, what should happen if I put my final result into Y2? They should look exactly the same, shouldn't they?
Yeah.
Okay, that was a huge waste of time on a calculator active problem. So now let's talk about what we're doing. It says to only get solutions from 0 to 2 pi. So I am going to, oh, by the way, the period of this one's 2 pi. When you have what's called a combined trig function, the period of that one's shortened to pi. But when you throw this one in, it's still going to take a while. Y'all see what I mean? This one really is going to make the period of this one 2 pi because this one's also being ground. All right? Anyway, make your window, which I expect you to be able to do, 0 to 2 pi. The other day I went a little bit before zeros just so I could see. 0 to 2 pi. I'll make my y, min and max, like -10 to 10 at first, but I change that a lot on trigonometry problems because sometimes that's too high if I don't have a big amplitude. Okay? And then I'm going to graph. All right, so get this funny combined trig graph. How many answers do you see that equal 0? Oh, did y'all get that graph? If you're following along, did everybody get that? All right, so look back at,
Wait, can you go back to
Is yours higher one?
here's my window.
Oh,
Okay.
So which part is the, I don't see where you did see which one. Oh, negative 1. Oh, so it's
Isabella, you're still not getting the right graph?
Make sure it's in radians.
Oh, yeah, check your mode. Thank you. Does that help?
yes.
There you go. Thanks, Chloe. All right. And Isabella, y'all listen.
Yeah, so it's on.
The instructions in the book said use your calculator. And they also said 0 to 2 pi. So they said, girls, please listen. You need to know this. I expect you to be able to. If it had said for us to do it from 0 to 360, we need to be in degrees, but our window needs to go to 360. Do you see why radians are so much better than degrees? I don't have to have such a big window to look at it. But you've got to think of all that stuff. Okay? What your amplitude and period and what mode you're in. All right, now, if you want to follow along with me to find those answers, look at what I'm quite literally looking for. I pulled these to this side. I'm looking for where this equals 0. So I'm going to go to second, calc, 0. And you move over here. There's ways to get there faster, but we're not worried about that right now. You've got to go to the left of it. All right. Enter. You're going to go to the right of it and hit enter. And you should see it boxed in. On guess, I never guess. I just hit enter. And how many decimal places do I want? 3. 0.861. All right, then you've got to do it again. Second, calc, 2. I'm going to move over here. Like I said, you can get there faster if you know how. Go for it. If you don't know how, I'm not going to give you something else to think about today. Hey, girls, another thing, just so you're good at this, you've got to, what just happened? I just lost my spider. Okay, I can't get there. I've got to get over the hump. This is, as far as I can tell, the program they're using something called Newton's method from Isaac Newton to find zeros. And you've got to get over there sort of close to it, or you'll literally go off on a tangent. I think that's where the phrase came from, but you don't want to know what Newton's method is, right? Oh. Anyway, you would go and find that. I keep messing up. Let me see if I can get there. I keep hitting the wrong button. Did y'all see what I just did? I got tired of moving the cursor, so I ended up showing you. I just didn't want to keep going la, 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 la. I just put in the number 5 and hit enter. I want my right bound to be 6. And so I'm going to hit enter, and it just lands me right over there somewhere, okay? You don't have to do that. Enter. I got probably a few people a while ago got 5.422. okay? I would never have been able to solve that algebraically,
Trace.
okay? Oh, please, girls, do not use trace. You will miss these problems. If you hit trace, it will not land on the zero.
It's like second trace. The button.
Right. But yeah, that wasn't directed. I don't even know who said it. But you realize that I see some people that aren't listening in class, and they actually are using the old-fashioned, maybe what you used to estimate with trace. I want a whole lot better estimate than trace. So second trace will take you to your calc buttons. Okay? All right, now, what does it appear the period? Okay, let's pause. Our answers are whatever I just called out, and there's only 2 from 0 to 2 pi. Hang on, let people catch up. Because what I'm going to say is important. I may can take Nicole's question in the meantime, though. Nicole?
So like if you were to do it not from like you know how we put the two equations together that were like on the opposite sides of the equal sign? Like if you were to just put those two in separately, then you just have to find where they
Intersect.
and that has to be at 0, right?
No, then you would, if they're equal to each other, you find out where they intersect, but you're looking at 2 crazy graphs at that point, and I just prefer not to do that.
Okay.
The only algebra I like to do is just at least level it out and get it 0.
Okay.
Hey girls, what Nicole's asking me is this. You could work it this way. I've had a conversation with a couple of people in this class and other classes recently, like, there's other ways to work problems, but I've done this forever and ever, and I'm always going to tell you the most efficient way to work the problem. I know all the different ways to work the problem because I've done this for so long and I'm so old, okay? And I really look at and change the way I teach on a lot of things that make things better. So please trust me, okay? You could easily watch a video where somebody actually even does the algebra and then grabs it, which I think is a huge waste of time. You're going to need your calculator on this problem anyway. Why risk making a careless mistake and you're not even working on the right problem? So please, especially those of you that take AP Calculus A, B, and don't take BC, I think Ms. O'Deal will say the same thing, but remember when you're on a calculator active problem, please do it in its purest form so you don't risk algebraic arithmetic mistakes that we all make. If you're going to use your calculator anyway, you should from the beginning, okay? Another thing is, I think you could tell the other class, okay? Just, we can use our calculator, you can't use your calculator, blah, blah, blah. You gotta really know your pre-cal to use your calculator here. There's no way you can pull this off if you don't know what in the world you're doing. This calculator is not going to answer these questions for you. I love using it because I think it makes you know your pre-cal better. You see a picture of it. You have to think through what am I seeing. You have to think through your window. It really emphasizes domain and range better than anything I could do for you. Also, it's very real world. You guys all know you're going to be working with computers and calculators. I have you exactly where you need to be, though, because I also don't want you working a problem that you could have worked faster without your calculator. There'll be a balance of all of that. Another thing I was going to say, though, is what Nicole was asking me. I could have, and I started out saying I could have put the left in Y1 and the right in Y2, and then I would have gone to second calc intersect. I would have 2 trig graphs. But y'all realize it's real hard to look at? What's the easiest thing to solve for is 0. Don't you see it? Okay? You see it. So I like to get my equations equal to 0 and use calc 0 when I can. All right, Elaine?
My calculator, when I do calc 0, it gets me like really close to y equals 0, but it's not y equals 0.
Oh, thank you. Sometimes this will say something like e to the negative 19, and it won't really flat out say 0. That's because this number, they're eventually having to estimate it because it's irrational. And so sometimes you'll get a number over here that's 0.00000000000000007, which is 0. It's just, see, it's rounded this one off, so sometimes when it rounds off 0, it's not quite landing on it. Elaine, is that what you're talking about?
Yeah.
She's seeing something, so thank you for bringing that up. I forget to tell people that. You might have like 5e to the negative 27 or something. That's okay. Go on with your life. Your calculator's just rounded this one, so it's not quite landing smack on 0. Okay? That will happen. All right, now, let me give you another example before we go, and I am getting it off this sheet, and it'll be what you're doing for homework, because we need to go in just a second. Okay, so I'm going to do
That's a funny picture.
okay, girls, listen. Shh. Real carefully, okay? Now I have a problem that I want to get rid of, okay? I actually don't want, I mean, I could successfully do it a little bit, but I'm not real wild about thinking of an angle that I double when I get the cosine to be 1/2. It's not just I want an angle that the cosine's 1/2. I'm like, oh no, now I've got to double an angle and find all of the ones that make it equal 1/2. That's not much fun. So put a Band-Aid on it. Give it a quick little fix to where it's just like when you skinned your, your knee and it really wasn't hurt, but your parent put a Band-Aid on it and made you feel better. Or maybe they kissed it, okay? So here's a little kiss. Let's just slap a Band-Aid on it and make it easy. And go, you'll be okay, all right? Just make it normal. On that last one, I don't remember what I had. All right, girls, shh, watch. I'm sorry, I'm doing 2 different things. Don't even write down what I just circled, okay? If that confuses you, you could have slapped a Band-Aid on it. You could have said, I don't want to do that. I'm going to let u be sine theta. So I get 4u squared minus 2u minus 3. And then doesn't that look normal to you? Notice I don't call it x. I don't want to do that, okay?
And why not?
Because x, oh, I'm sorry, I could call it x. I thought these were x's. You don't want to reuse the same variable. But it's very typical. Every book and pre-cal and calculus calls it u substitution. It's just our Band-Aid, okay? Now, if somebody walked in, they'd go, well, I thought y'all were in honors pre-cal, okay? Why are you doing cosine theta equals 1/2, all right? So I'm going to find all the solutions from 0 to 2 pi, by the way. All right, cosine's 1/2 at pi over 3, and again at 5 pi over 3. Okay? All students take calculus. However, I just solved for u, right? Now I need to rip the Band-Aid off and put back in what? What was u? 2 theta. And what was your job? Your job was to solve for theta, right? Or divide by 2 or multiply by 1/2. So I'm going to solve for theta. So theta, if I divide by 2 or multiply by 1/2, I get pi over 6 and 5 pi over 6. Girls, I'm not going to wait on the graphing calculator right now, but y'all all know cosine 2 theta looks like this. I'm sorry, I didn't spread it out very well up and down the axis, the midline, but do y'all get my drift? Do you see what I'm saying? What's the period of this? What's the period of cosine 2 theta? Pi. And I wanted you to find all the answers from 0 to 2 pi. And how many times does this hit 1/2? 1, 2, 3, 4. So what you're going to do is if it says cosine 2 theta, go around twice. Okay? If it says 3 theta, how many times are you going to go around? 3 to make sure you get them all. Y'all, even if you're packing up, you have got to keep listening. I've got a minute. I'm going to take it. All right? How do you go around again? If it's degrees, you would go right back where you started by adding 360. So how will I go around again to get the next cycle that I'm missing? Add 2 pi, which is 6 pi over 3. So my next one around, well, 6 pi over 3 and pi over 3 is 7 pi over 3. And what's 6 and 5? 11. All right, and then Pietro, like you said, we're going to multiply by 1/2. So that gives us 7 pi over 6 and 11 pi over 6. Did those all make it between 0 and 2 pi? Okay. So if I have tan 3 theta equals 1, I'm going to say tan u equals 1. But when I go to say my answers, tangent's 1 at pi over 4 and 5 pi over 4. Can I stop there? I need another set and another set, right? add 2 pi to them to get this set and this set. And then in the end, how will you solve for theta? Multiply by 1/3. All right, so as you are leaving, this is what's happening. You're treating it like a normal tangent graph. Is this positive or no? Yeah. So you're going out 1, 2, 3, which is way too far. But when you divide them all by 3, what does it do to the whole thing? It shrinks them back down into the period that you should have. All right? So you have very few homework problems.